This is the first of the 3 questions that I gave you yesterday to solve. And I said you could use any method that you want to solve that. What method do you think we should use for that one? Elimination? Substitution? Doesn't matter, right? It's your choice. This one is actually easy to do either way, but I like elimination, so I think that's what I'll do. The first one I'm not going to change at all. What do I have to multiply the second one by? 2. We're going to eliminate the x's. So that's negative 4x minus 2y equals negative 2. Add them together. We eliminate the x's. 4y equals negative 12. And then divide by 4 and we get y equals negative 3. That's easy enough. Then we need to figure out what x is. So take either of the original equations and solve for x. But instead of putting y, we're putting in what y is equal to. So this becomes 4x minus 18 equals negative 10. And 4x equals, we're going to add 18, so 8. Divide by 4 and we get x equals 2. Is that what you got for that first one from yesterday that was written on the board? 2 and negative 3. If we think about this one graphically, what does that mean, that answer of 2 and negative 3? Do you understand how those numbers relate to a graphical solution? That's where the 2 lines intersect. So if we look at the graph here, I just graphed these 2. You can see the equations there. 4x plus 6y equals negative 10. Negative 2x minus y equals negative 1. And they intersect at that point 2, negative 3. That's the kind of answer you will most often get when you're solving a system of equations is one x value, one y value, where the lines intersect. If you were to solve this graphically, either on paper or on your calculator, you would have to rearrange these equations to figure out what y equals, right? Isolate the y and then graph. But that's what you end up with is one point of intersection. When we look at this one, x plus y equals negative 2, do you think we should solve this one by elimination or substitution? Substitution. It's easy to isolate either the x or the y at the beginning, right? Which one do you want to isolate? X. So this becomes x equals negative 2 minus y when you subtract y from both sides. And then fill it in over here. So we go negative 2 times negative 2 minus y minus 2y equals 4. Expand. Negative 2 times negative 2 is 4 plus 2y minus 2y equals 4. Simplify. Plus 2y minus 2y is nothing, so I end up with 4 equals 4. Did I make a mistake? Did anyone try elimination?
No.
No. It gave you 0 equals 0 when you did elimination? So what's happening is the x's and the y's are canceling out. What does that mean in terms of a solution? I don't know. Maybe you know. But I thought, let's look at it graphically. And when I graph those two, here's what I get.
They're the same.
They're the same line. Right. They have the same slope and the same y-intercept. If you were to isolate the y in both of them, you would get y equals negative x minus 2 for both of them. So they have the same slope, the same y-intercept. They are the exact same line. So there's not a point where they intersect like there is in most of them. Where do these ones intersect?
Everywhere.
Everywhere along that line. So, for example, a solution could be -2, 0. Or it could be -3, 1. Or it could be 2, -4. Every point on the line is a point of intersection. And so what we say for one like this is that there are an infinite number of solutions. Or sometimes we'll write it as infinitely many solutions. Or an infinite number of solutions. That's what happens when the two lines are the same. So if they have the same slope and the same y-intercept. If you're trying to solve algebraically, either by substitution or elimination, you're going to end up with something like this. Here we had 4 = 4. Those people that did it by elimination had 0 = 0. Both of those are true statements, right? 4 does equal 4, and 0 does equal 0. So if you get everything canceling out, all of the variables canceling out, and you're left with a true statement, like 4 = 4, or 0 = 0, something like that, then you know that there are an infinite number of solutions. Here's one more. 3x + y = -1. -6x - 2y = 12. Elimination or substitution? What do you want to try? Substitution again? Isolate the y in the first one? You could use either method easily. It's your choice. If we use substitution, y = -1 - 3x. And then substitute it in for y, -6x - 2 times -1 - 3x = 12. We get -6x + 2 + 6x = 12. And then add the like terms. -6x and 6x are gone, and you end up with this 2 = 12. Does 2 = 12? No, 2 = 2. Here, with this one, we get a false statement. It's not an infinite number of solutions. It's something different. If we look at graphing it, here's what we get. Two parallel lines. And do you know what parallel means?
Yeah.
Yeah.
Beside each other.
Beside each other, and they never...
They don't cross.
Yeah, they don't cross. They never intersect, which means that there is no solution. No solution for this one. This is what happens when you get two parallel lines. And if you think back to the section on linear functions, let's just look at isolating the y in each of these equations. The first one becomes y = -3x - 1. The second one becomes y = -3x + 6. These two lines are parallel. They have the same slope, but they're not the same line because they have different y-intercepts. So graphically, for there to be no solution, it has to be two equations that have the same slope, but different y-intercepts. Algebraically, for there to be no solution, after you go through the process of either elimination or substitution, you end up with a false statement, like 2 = 12. That's how you can tell whether it has one solution, no solutions, or infinitely many solutions. And those are the only possibilities, right? Could you ever have two solutions? Or three?
No.
No, it's just one or none or an infinite number of solutions.